So in this video we'll be analyzing patient survival after 1 year of treatment. So we'll be using machine learning to predict the survival of patients after their 1 year of treatment, right? So the first thing that I'm going to do is I'm going to import the dependencies. The next thing is I'm going to assign this variable data, and then we are going to read the data using the read CSV function from pandas. And then we are going to display the first 5 items in our dataset using the head function. So now the next thing that we are going to do is we want to read all the treated with drugs value counts. This will return all the values in our column treated with drugs here, in our column treated with drugs. So if we analyze our treated with drugs values, we can see that we have some values are in uppercase and some values are in lowercase. So we need to change those values into uppercase. So what we do is select the column treated with drugs is equals to the column treated drugs to convert the string into uppercase using the dot upper. And then if we select again the treated with drugs column, we can see that now all our values are in uppercase. And then we are going to analyze the patient column. So there are two ways of doing it to access columns. There's this one where we use the data and then open square brackets, and then we put the name of the column, or we can do it directly by data dot patient smoker, which is the column name, dot value counts. This is going to return all the values in our patient smoker. We have no, yes, no, yes, yes, yes. As you can see here, what's happening is that maybe this no is a no without a space. Here the yes, it's a yes without a space. Here it's a no with a space, yes without a space. So as you can see that we only have 3 categories here: no, yes, and cannot say. But somehow we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 categories. So what we need to do is we're going to use a function def smoke, which is going to accept a value r. If r is equals to no, or r is equals to no with spaces, we are going to just return no. Or else if r is equals to yes, or yes with the space, or yes with the double s, or yes with the double s and space, we are going to return yes. Else we are going to return cannot say. So now we are going to say we are going to select our column, and then we are going to apply our smoker we are going to apply our smoker function to convert our values into 3 categories. And then we have data patient rural urban value. So we have patients from rural areas and patients from urban. We can see that we have 17,482 from rural areas and 7,597 from urban areas. And then we have patient mental condition value counts. We have 25,000 who are stable. And then now we are going to perform what we call exploratory data analysis. So exploratory data analysis is a way in which we analyze our features and we analyze our features and get the meaning. What are the features telling us, right? So now we are going to plot a histogram SNS.count plots with our x value survived the first year of treatment, and then our y value or our data is going to be our data set, right? As you can see that almost 9,000 patients did not survive after the first year of treatment, and then something like 16,000 survived after the first year of treatment, right? So now we'll perform EDA on continuous variables. So continuous variables are variables with numbers, right, that represent numbers. So we are going to say numeric features is equals to data, our data, remember our data variable, dot select d types. This is a pandas library. Select d types, data dot select d types, include np dot number. So what this is doing is just telling us that we only want numbers, right? And then numeric features dot columns. Now this is going to display features with columns only. We have the ID, patient case situation, diagnosed condition, patient ID, patient age, patient body mass index. This is the patient mental condition. These ones, they are categories from A to Z, and then number of previous condition, and then we have survived first year. So now what we are going to do is, now that we have, these are our features, but as you know that the ID, patient case situation, and the patient ID, the patient ID is used to identify a unique patient, and then ID, patient case situation, I think this is going to identify the situation of each and every patient. So these two are not useful in our machine learning algorithm. So what we are going to do is, we are going to say, we are going to create another data frame. Numeric data is equals to diagnosed condition, patient age, patient body mass index, number of previous condition, and then survive first year. And then we are going to display the first 5 items, and then you can see now we have our numeric data. And then the next thing that we are going to do is, we are going to check for null values. Since we do not want to input data missing values in our machine learning models, because that would disrupt the performance of our machine learning models, and also that will also compromise our prediction. So now we can see that number of previous conditions, we have 1,356 missing values. So what we now do what we can do to fill those missing values, we select the number of previous conditions, data, number of previous conditions, data, number of previous condition. We then fill the number of previous conditions. We then fill the number of previous condition column using the fill NA, which is a library from pandas to fill null values, with the mod. So what is the mod? So the mod is the number that appears the mod. So I think you can even use the mean and the median, right? And then we can now say numeric data is equals to data number of previous condition, since now we now have all our values are now filled. So now we now check for null values. As you can see, now we do not have null values. So let's look at basic statistical distribution of our numerical columns. You can see that we have the count, the mean, which is the average, standard deviation, which shows how our values are spread around the mean. We have the minimum, we have the lower quartile, we have the lower quartile, upper quartile, and then we have the median quartile, and then we have the maximum value. And then observations. As you can see, the minimum and maximum values are values for all numerical columns. The mean and median 50% value of all numerical columns are nearly the same. A good way to visualize the information would be to use box plots. So what are box plots? So box plot is a great way to visualize, to get a visual sense of the entire range of data. It can tell about outliers or what their values are. It can also tell you if your data is symmetrical, how tightly your data is grouped, if and how your data is skewed, right? So in the box plot, we have the minimum value, the first quartile, the median, the third quartile, and then the maximum value. So what we need to do to plot box plot, we are going to drop the survived first year column. Since this survived first year column is not our feature, this is our target variable, so we need to drop it. So we are going to loop through the entire survived first year column, and we drop it. So we say for feature in numerical data that drop survive first year, x is equals to 1 shows that along columns s, and then we're going to use sns dot box plot survive the first year as our x value, y is our feature, and then data we're going to input our numeric data, and then we are going to use pot.show to visualize our data set. As you can see, diagnosed condition, patient age, patient body mass index, and then number of previous condition. So guys, I'm not going to tell you to explain further how we can interpret our data using box plots, but what I'm going to do is I'm going to put links in the description that will help you to understand box plots, right? So data is now dot sum. So now we are going to look at our categorical features. Remember, we are looking at numerical features. What are categorical features? So categorical features are features that represent categories, like yes, is a patient a smoker, yes or no. Those are categorical features. As you can see, the patient mental condition, A condition, we have 1556 missing values. Same goes for B, C, D, E, up to and Z. So we need to fill those missing values. So what we are going to do is we are going to also treat it with drugs as missing values. So what we are going to do is as 8 missing values treated with the drugs. We are going to select the treated with drugs column is equal to treated with drugs column, fill the missing values with fill NA function, and then we are going to use treated with drugs dot mode. We are going to fill with the number that appears the most. The same we are going to do for patient mental condition categories A, B, C, D, and E, right? So let me just run the kernels. As you can see, now we do not have any missing values. So EDA on categorical data, we are going to perform exploratory data analysis on categorical data. So what we are going to do to select the categorical data is we are going to drop the numerical data from our main data frame, which is from the data variable. So categorical data is equals to data dot drop numerical data dot columns x is equals to 1. So we are going to drop numerical data columns. So categorical data dot drop patient, we are also going to drop the patient ID, patient case situation, and then if we run, we can see that now we are left with categorical data. Treated drugs, these are categories for drugs. Patient smoker, no. Patient raw, urban, rural, and then patient condition, right? So the next thing that we are going to do is categorical data dot n unique. As you can see, that treated with drugs has 64 unique values. Patient smoker has 3 unique categories. Patient rural has 2 unique. Patient mental condition has 1. A has 2. So now what we need to do is for feature in patient smoker, patient rural urban, patient mental condition, we are going to plot a histogram with our features. X is our feature, and then we are going to provide the data as survived. The data is survived first year, and then the data is going to be the categorical data. The who is going to be the survived first year. The data is going to be the categorical data, and then what we are going POT.fix size 15.5. This is the size. This is going to be the size. This is going to be the size of each histogram. And then xns.count plot, we are going to our x value is treated drugs, survive first year, and then data is equals to categorical. Let's see. So as you can see, if a patient is a smoker, for non-smokers, we can see that 10,000 people survived for non-smokers, and then something like 4,000 did not survive for non-smokers. As you can see here, almost 5,000 smokers survived first year of treatment, and almost 5,000 smokers did not survive first year of treatment. If you compare these two, we can see that non-smokers are more likely to survive as compared to smokers. The next thing is patient rural urban. We can see that from urban areas, we can see that almost 4,000 survived after first year of treatment, and almost something like 3,800 did not survive after first year of treatment. And then we can see that in rural areas, almost 6,000 did not survive after first year of treatment, and then something like 12,000 survived after first year of treatment. So that tells us that people in rural areas are more likely to survive after first year of treatment. And then we can see that patient mental condition, we can see that stable. people with stable mental conditions are more likely to survive as compared to people who are not stable mentally. So this is the insight that we gain from our features. So then, oh, I think I made a mistake somewhere. So the next thing that we are going is pre-processing and data cleaning of categorical variables. Guys, remember when dealing with machine learning models can only understand numbers. So as they understand numbers, what we need to do is we need to convert our categorical features into dummy variables. So what are dummy variables? For example, if a person is a smoker, if a variable if a person is a smoker is represented by yes, we are going to input that by 1. If he's a non-smoker, we are going to input that by 0. So drugs, treated with drugs column, string dot get dummies separated by space, drug dot head. As you can see now we have converted. So that means the 1 means that this person dx1 was treated with drugs dx1, 0 was not treated with drug dx1, 1 represents presence of dx1, 0 that means that dx2 is not present, 1 represents dx6 is present, 0 means dx6 is not present. So now what we do is we are going to concatenate it into our data. Say data.pd.concat data, and then we are going to concat our drugs variable here with the dummy variables into our main data frame, right? Data is equals to, and then we are going to drop the treated with drugs since this does not contain dummy variables. So now what we get is we have categorical features for our treated with drugs. Patient smoker is also a categorical column. We need to create dummy variables for it too. As you can see, we have yes or no, cannot say. But cannot say, we cannot say it's a category. Since someone says cannot say, we can just classify it as no. So what you do is data.patient column patient smoker. If it's equal to cannot say, then we need to convert it into no. And then the next thing is mental condition, patient mental condition. We are going to drop this patient mental condition since we only have one value which is stable, so it does not give us any other meaningful insight. And then we get data.get dummies. We want to input dummy variables for patient smoker and rural to urban. As you can see, now we have dummy variables into our data set. So the other two variables I told you about are the ID columns, the ID, patient case situation, and patient ID. We can think of removing these columns if these are randomly generated value and there is not any ID repeated like we had in the passenger ID. So we are going to change these. We are going to drop these values since they are generated values and they don't give us any meaningful insight. So since they don't give us any meaningful insight, so now what we can do is we can drop the ID patient care situation. We can drop the ID patient care situation. Now what we are going to do is prepare our training and test data. So for our X data, we are going to drop the survived first year since it's not our feature, it's a target variable, and then we are going to assign it to the Y variable, right? The next thing is we are going to split our data set into training and test set using the train test split. X train, X test, Y train, Y test is equal to train test split X, Y. Want our test size to be 20% of the data set, random state is equal to 1. And then our classifiers, we are going to create a dictionary for our classifiers. So we have our key, logistic regression, instance of logistic regression classifier, k nearest neighbor, and then we have the nearest neighbor classifier, key for support vector machine, support vector classifier, decision tree classifier, decision tree classifier, other boost classifier, other boost classifier. So now from sklearn.model selection import cross validation score. So this is going to give us validation score for our model. For key and then our classifier, this is our key classifier. In classifiers.items, this is our classifier.items. We are going to loop through this dictionary, and then we are going to fit each and every classifier to our training and test set. And then training score is equals to cross validation score. Classifier, we're going to provide this classifier x train, y train, and then we are going to provide a CV is equals to 5, and then we are going to print our classifiers, classifiers.class, classifier.name, and then we are going to print also the accuracy of our classifier. And then we are going to name x train. I think I did not run this. And then after our modules are done, we are going to plot a confusion matrix for our modules to see how it correctly classified and how it misclassified our data set. And then so now the classifiers are training. So what I'm just going to do is I'm just going to pause the video, and then I'll come back when it's done training. Hello guys, and welcome back. Now that our model has finished training, we can see that the best classifiers are other boost and gradient boosting classifiers. So I selected the other boost and the gradient boosting classifiers, and I used them to plot a confusion matrix. As you can see, these are their confusion matrices here. And then from sklearn import classification report to then paste the y test actual values, and then the predictions of other boost, actual values, predictions of the gradient boosting, precision, recall. So what you can see what we can see from this is that our recall for other boost, our recall is 90%, our precision is 84, and then our accuracy is 83. So recall is the true positives divided by the total number of actual positives, and then the precision is the total number of true positives divided by the total number of predicted positive, right? So precision, and as you can see, other boost has a precision of 84, and then gradient boosting has a precision of 86. So as you can see that other boost is actually classifying more, is actually performing well as compared to other boost, but the difference is slightly low. So thank you for watching, guys. If you've watched this video, please make sure you share this video with your friends, and also you can also, as a homework, you can also try to implement neural networks, or try to implement other machine learning algorithms. Thanks for watching, guys. Cheers.